chips throughout this. I'm going to get snacky every once in a while. Well, I think we have enough people in here to start. All right. So this is our second paper from Anthony Leonardi, who's sort of like a leader in the field of COVID in terms of our immune system response to COVID. So this paper is titled Uncertainty Around the Long-Term Implications of COVID. Let me zoom in a little more for you guys. There we go. That looks good. Okay. I'm gonna grab some chips too then. Yeah, by all means. Mine are corn chips so that they don't upset my tum-tum. Severe, I have to get contact lenses found out. My full respirator has a leak when wearing glasses. Oh no! Yeah, contact lenses definitely one way to go. Other ways, for glasses, cup mask and boat masks seem to be the best for those. I don't really have issues with my duckbill masks, but again, they're not very sightly. They're kind of ugly. But yeah, there are definitely options out there. I have if you go to my link tree, the first link in the link tree is for masks. You can down select from there and help to find like an N95 cup mask or boat mask. Let me show you real quick what that is. Just because I want to make people aware of this, and then we'll jump back to the paper. COVID. Do I throw it in here? Daily cases, wastewater papers, TikTok video backups, wastewater scan data processing, TikTok survey. Oh, here we go. Date modified. 803. This one. So this is available for download through the link. It's called Notion website. This isn't right. There we go. Excel workbook. That's the one we want. I was testing out doing CSV uploads, and then I ended up having to pay for the Excel extension. This is a thing I'm tracking for people that get sick with COVID that tell me about it. Alrighty, so this is something I made. It has a bunch of different masks from Project N95 that I linked in here to help people choose. So if you like, do you like over ear straps or behind the head straps? Otherwise, I can just do like an example. Yeah, no problem. But just for other people, I guess I'll just go through it. So like for me, and this will be good because I actually want to upgrade. So I like behind the head. So you just like go to the, click on the filter. You can deselect them all. I like behind the head, and then I'll down select for all behind the head. What's that? Okay, so update. And then I want a 95 masks. They're already selected. And then I need either a universal size or a medium size. I'll down select again. And then I can select for face shape. I don't really care about face shape. And then these would be all the different options that fit me. Let me see if I can down select a little more. Cool. So and then I can like scroll through. I like ones with a nose bridge, so I'll make sure it has an adjustable nose bridge. So I think I'll probably go with this one, which is Extreme Comfort 3230 Surgical N95. And then you just have to scroll over to the link, click on it, and then it'll redirect you to the website where you can purchase it. So this one, I can get a box of 50 for 14 bucks, which is a good deal. So then I'm just gonna save that for later. But that's just a little resource I made. So I think it's cool. Anyways, back to the paper. That is extensive. Yeah, it took me a while to make. I spent a lot of last week doing that. Back to the paper. So severe acute respiratory syndrome, SARS-CoV-2, has infected more than 231 million people globally, with more than 4.7 million deaths. So let's look at this is a paper from 2021, so the numbers are going to be much higher because we're in 2023 going into 2024. I was like, those numbers don't look right. So in response to the pandemic, some countries, New Zealand, Vietnam, Taiwan, South Korea, and others have pursued suppression strategies, so-called zero COVID policies. I'm gonna highlight that. To drive and maintain infection rates as close to zero as possible and respond aggressively to new cases. In comparison, European countries and North America have adopted mitigation strategies of varying intensity and effectiveness. With recent advances in our understanding of COVID and its biology and the increasing recognition that there is more COVID beyond the acute infection, we offer, there is more to COVID beyond the acute infection. We offer a perspective on some of the long-term risks of mutational escape, viral persistence, reinfection, immune dysregulation, neurological and multi-system complications like long COVID or multi-system inflammatory syndrome complex, multi-inflammatory syndrome in children, MISC. That's the other one. So I'll highlight that. So that's sort of what they're looking at. I'll do a quick save. Save. Thanks. I had to wear something with a face shield, then I heard a whistle. Thanks, Patrick, for Rex. Oh, wow, that is excessive. Nice. Okay, so moving into the introduction. Severe acute respiratory syndrome coronavirus 2, SARS-CoV-2, has infected more than blah, 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 blah. We already know all this. This is old information. At the present, there are high levels of community transmission in several countries around the world. That's the definition of a pandemic. With daily cases in the tens of thousands, scientists concerned about the strategy have called for a pan-European strategy aimed at suppression, which is true. We need a global response to be able to contain COVID and to get it back under control at this point in time. With recent advances in our understanding of COVID and its biology and the increasing recognition that there is more to COVID beyond the acute infection, it is clear there are several risks inherent in strategies that are unable to prevent surges in community transmission. We offer a perspective here on those here and summarize the key findings in Table 1. So first, we're going to look at viral evolution. So vaccines rely on the induction of neutralizing antibodies to the virus. This is what happens when you get vaccinated. You develop neutralizing antibodies. This is what we call our active immunity. And they have high levels of this active immunity of the neutralizing antibodies, which will transition over time more into memory immunity. That's how they work. So high levels of community transmission increase the risk of mutations that can escape neutralizing antibodies, potentially rendering vaccines less effective. Because the more people that are infected, the more chances the virus has to mutate. because it's using different people's bodies to replicate, which means there's different controllers, different sets of instructions, different ways it's going to be read. Basically, it's just working with a different typewriter, a different machine each time. It tries to replicate itself, and it's not that great at replicating itself. It makes mutations by trying to replicate itself very, very quickly, very rapidly, and these are all things that can happen. So variant B1352, now known as beta. So they're looking at the beta. This is around the time of the beta coronavirus one. So there's alpha, beta, delta, that phase of the pandemic. So it was right before delta. This was first identified in South Africa and showed evidence of escape from convalescent sera and potentially reduced vaccine effectiveness. So it's saying that it was one of the earlier ones that showed escape immunity, the ability for the virus to evolve to a point where the vaccines aren't as effective as they were against previous versions, ones that were not as mutated. And it's already circulating in at least 32 countries. Variant P1, now known as Gamma, spread rapidly across the Manaus, I don't know where that is, at a point when an estimated 76% of the population was thought to have been exposed to COVID during the first wave. So the implication of that right here with Gamma is that despite people being infected, their previous infection was not conferring immunity against the Gamma variant at that time, which shows that previous infections were not going to protect you against these future mutations. So, and then the variant Delta was more transmissible and showed an 8-fold decrease in neutralization by vaccine sera. So not only did you have the beta, which is more immune evasive, and the gamma, which was also even more immune evasive, then you had Delta, which became even more transmissible. So it had two things. It was it can infect more people, and it was immune evasive, which led to it being such a predominant thing when we were going through that phase of the pandemic. And then the plasticity of the immunodominant, that's a fun word. Immunodominant domain of the viral spike protein allows mutations to occur without disrupting ACE2 receptor binding necessary for COVID infection. So that's just a fancy way of saying that the spike protein can change pretty significantly, but still bind to the ACE2 receptor. And that has important implications for mutational escape. So that's what we mean when we say escape variants that have mutated far enough away that they can escape our immune system. If you're thinking of our immune system like cops and robbers, where the cops are trying to track them down and stop them from doing the bad thing, they can escape that defense. And this type of thing has been suggested for human coronavirus, HCOV229E, the introduction of a mutated variant of the virus through the mink population in Denmark, reported to potentially be less sensitive to neutralizing antibodies, also raises the possibility of reintroduction of divergent strains through animal populations that could pose a risk. And that's like the other side of the coin is, so this is a zoonotic disease. It came originally from bats. Bats were the original source of the coronavirus in this case, and then it spread at a local market to humans. It made that jump, and now we've seen that humans can then reinfect other animals. There's been white-tailed deer that have shown this. Apparently minks have also done this, and then we've also found that humans have been able to reinfect bats with coronavirus, and it's mutated further in bats, and they're actually monitoring some specific fruit bats that have had these mutations to see if it's going to jump back into humans, because it's mutated pretty significantly in these fruit bats. So that's something that they've been monitoring. They haven't seen it jump back in, but that's another risk of allowing for this further mutation for the risk. I'm sorry, one of the many things professionals are trying to protect people from. What do you mean? I must have missed something. I don't know. I'm gonna keep going. We'll control save. So that's another risk for that can allow for mutation. Someone's revving their motorcycle outside. Allow for mutations is through animals. So vaccines are a major factor in bringing pandemics under control and require significant development time and investment. With a number of vaccines authorized and now in use around the world, every effort should be made to give vaccines the best chance of success. And this means providing it to the largest number of people, to healthy people that can generate adequate immunity to it, to immunocompromised people that need even more vaccinations to achieve the same level, equivalent immunity. And we found that they can achieve equivalent immunity, but it takes about 4 vaccinations to do that. So with the number of vaccines, I already read that sentence. While vaccines may be amenable to updating, this will take time and trialing across populations, during which lives may continue to be lost. And that's sort of what we're seeing now because of all the regulational loopholes and this push by our government to only do an annual vaccine update, as opposed to what we need, in my opinion, is 4 vaccines a year. So like those types of actions are costing lives because we're not getting the vaccines we need when we need them. And then my voice is getting sore from talking, so I'm going to drink some water. So even though coronavirus like COVID possesses an RNA proofreading mechanism, the virus has proven to be adaptive in allowing transmission at a level that increases the probability of mutational escape risks, more efficient human-to-human transmission, which may seriously undermine this strategy. So I think that just saying that because we're not really doing anything about it, we're allowing it to just go unchecked, that increases the mutation risk. So immune escape is not the only long-term risk of continued evolution. Transmissibility and disease severity can increase as a result of evolution. We've actually seen this. So I have a playlist where you look through, where you can look through the transmission of COVID. I've been tracking this. I've been tracking the variant evolution in that playlist. And what we found is that the original Wuhan strain, it took about 15 minutes to infect someone, and you needed a high number of virions to do that. And then by Delta, that time cut in half. You only need like 8 minutes to infect someone. And then now with current variants, you can infect someone else within 30 seconds to a minute of time. So the transmissibility has increased. You need less virions to become infected, and also people emit more virus for a longer period of time. Well, I shouldn't say a longer period of time, but they're having higher levels for longer periods and at later periods from when symptoms initiate. And a study of the impact of variants of concern on disease severity concluded that there was a signal towards increased disease severity associated with Delta variant and a lower CT value. So the lower the CT value, the more severe the disease course is. I'm sorry, one of the many things professionals are trying to protect people from. Okay. In longer viral shedding, that could provide a mechanism for increased transmissibility, which is what we just talked about. So some researchers expect continued evolution will attenuate the virus over time, and that's the big theory that people have been saying, but it just has not proved to be the case whatsoever. It's just been becoming more efficient over time. It's not been resulting in milder disease courses. It has not been resulting in less severe infections. That's all been false. People that say that are lying to you or don't understand. So that doesn't happen. But even if this happens, it is difficult to predict how long this process might take And so far, new variants of concern have corresponded with an increase in disease severity, which is essentially what I just said. And this was in 2021, we're in 2023 now, and this trend has only continued. Population, so much so that the craziest thing that no one is talking about is that we've had in the US, we've had increases in COVID deaths over the past 20 weeks. Like, there were only 4 weeks where we didn't have increases, and that's where it held constant from the previous week. And no one is talking about this, and I don't understand. Like, deaths from COVID have been going up. Sorry, sometimes I think faster than I talk, and sometimes I get jumbled. But reminder for a water break. Oops. You think it's due to long COVID? I do. I think, is there a way to boost your love to try to get others in here? Boost your live. Maybe. I really don't know. I don't know too much about lives. I know you can share lives, but that always depends, like, if the person you're sharing with is online, and then like if they even want to join. But I don't think so. And don't feel the need to. You don't have to. Most of this is just for fun for me. And what do you think is due to long COVID? For Ingus, tap screen sharing, and that's about all I know. Same. That's all I know. I truly don't understand TikTok in some ways. But what was your question about long COVID being due to long COVID? I'm gonna keep reading, but I'll look back for it in a little bit. So population immunity may blunt the impact of increased virulence and or transmissibility, but when combined with a degree of immunity escape or waning immunity, such evolution can prove problematic. And that's the thing, like, we have viruses that are amping up their evolution. We're in the quote-unquote variant soup. I initially did not like that phrase, but now I kind of like it. Because I think people where it originated from, in my opinion, is people are like, oh, it's like alphabet soup. There's so many letters, you just can't keep track of them. And that's why I have always done these air quotes, and that's why I didn't like it, because it's not alphabet soup. They have meaning. Everything is important. You should learn it. You should understand it. But then, like the great mixing pot of America that you got taught, that's sort of a great mixing pot of COVID variants. So I like the soup when you think of it in that type of way. But we've got many variants out there, and a lot of them are highly transmissible, can cause slightly different symptoms, can do different severity, different durations of disease. So you have all of these large array of different variants that are going to have an escape immunity. And then when you're only immunizing your population one time a year, and immunity wanes by 6 months, really 4 months, but by 6 months, for active immunity from vaccination, then, like, we have these long periods of time where people don't have that protection. My question, the death increased. Oh, no, I don't think the death increase is due to long COVID. I mean, no, not yet. I think in like 10 years, the death increases will be due to long COVID. I think that current variants are likely causing more severe disease, which is resulting in death. I think one of the variants out there, and my guess is actually HV1. I don't think that it's the JN one, but I think it's significant enough to kill people. But looping back to my statement about the long term, I think that people with long COVID might end up with shorter lifespans due to the chronic issues from it. And I think we'll see that within a decade, unfortunately. But for the current deaths, I think it's correlating more so with the EG5 variant family because we started seeing this 20 weeks ago, which is around the time that EG5 started coming on the scene. So I think that family is contributing to those deaths as opposed to this the new one. This is all speculation. Don't quote me. But that's my guess. And then, so we talked about that. And then it's just gonna, like, the evolution is only gonna get faster and faster and faster because the more variants we get, the more it's like having a chaotic system. If you've studied mathematics, and I would really encourage you to like look into chaos theory in terms of mathematics. But the easiest way to think about it is if you have a bunch of marbles on the floor and you have one energetic marble and you flick it into the marble, then you'll have two marbles going, and then those marbles will hit more marbles, and those other marbles will hit even more marbles, and we're assuming a frictionless scenario here. And then you'll just have all of this chaotic motion going around. And that's what each of these COVID variants are. I think that we're only going to see increases, dramatic increases in variants from here on out. And they're only going to be getting more severe over time, whether that's due to people not having protection from their immune systems being damaged each time, whether that's from just the random chance that they just become super deadly. I don't know. I don't have a lot of hope for that, but this is the big issue with evolution, the evolution of it. I'm careful, had COVID last December, and I actually feel a lot older and much worse health-wise. Yeah, so they're actually seeing that a lot of the body structures appear to age several years. The thalamus in particular can, after a COVID infection, I haven't read a paper on this, but I saw a quote from a PhD person that was saying that the thalamus looked like it had aged 5 to 10 years after a COVID infection in their patients they were looking at. So I think there is some merit to that statement of yours. Everything I had is much worse. Yes, and any like weak points in our bodies are going to be even more exacerbated. I think that if I get COVID, if when, I don't know at this point, but if I get COVID, my weak point is my gut. From my norovirus infection that killed me, made me develop gluten intolerance. So like my gut is sort of my weak point, and a history of like colon cancer runs in my family. So like I think that if I get it, it's gonna target there and cause my issues there. That's my weak point in my body, as well as my heart. So what do you think about Covixel V and Xclear and nasal irrigation lavage with 1% iodine? The only thing I've read about so far with the nasal stuff is nitric oxide. Nitric oxide is good for reducing viral load if you already have a COVID infection. It did not seem to have any effect for preventing COVID infections. And for people that have the COVID infection and are using the spray to help reduce their viral load, and this is for nitric oxide sprays only. I think Covixel is one of them. We looked at it earlier. I think Xclear was a different ingredient. It did not have nitric oxide. It had xylitol, and I have not looked at xylitol's effect on COVID, so I can't speak to that one. I also can't speak to the nasal lavage with the iodine, or some people have been doing salt solution lavages. I can't speak to that either. But at least for the nitric oxide, it doesn't do anything for prevention. There was no effect. But for people that had it, it ended up clearing the virus a couple days faster. And they spread less there's less transmission, like infectious virus particles, because but you have to spray 2 times each nostril. And one study looked at every 3 or 4 hours, and another study looked at every 6 hours. So you have to use a lot of it, and there's only like 24 sprays a bottle, so you have to buy a bunch of that. It was in the papers we reviewed was in another one of these lives. So if you go to my YouTube and you look back for the nasal spray stuff, it'll be there. I lost my mind in all of 2020. My fears from then are coming true now. Yeah. So Covixel is a nitric oxide spray. Yes, I believe it is. Just Google it and look in the active ingredients, and if it's a nitric oxide spray, it'll be good for reducing viral load if you have COVID. Because you understand passive viruses added too. I was so hopeful with first vaccine. Same, so hopeful. Cool. Drink some water. These are such vocal exercises for me. So sore. So next we're looking at viral or antigenic persistence. There is some evidence to suggest that human coronaviruses, like animal coronaviruses, may be capable of persistence in the host in a low replication state. We have seen that this is 100% true. Yellow. Persistent shedding of the virus in nasopharyngeal swabs and fecal samples has been reported for up to 6 weeks among hospitalized patients. We've seen much longer. There's been cryptic lineage cases of people shedding feces, COVID in the feces, in the wastewater for upwards of 2 or 3 years. So it can last for a very, very long time. What will it have in the ingredients to prove it'll say nitric oxide. It'll say that's the ingredient. I have to go. Keep up the good work. I try to boost as much as possible. Good. I'm glad. And thanks for stopping by. You could do vocal warm-ups like choir practice stuff. It truly helps. I could guide you. Yeah. Yeah. I like all week I sit at my desk because I work remotely, and I sit here and I barely talk to anyone. I have a couple calls a day, and then I do these, and I am just talking for hours. And I already did one for like almost 3 hours earlier today, and this is my second one. We're at 32 minutes. My voice is just but also like part of it is like the gluten thing, like it's doing something to my jaw is like the last part of the stiffness. So I think that's playing a minor effect as well, but mostly it's the fact that I barely talk out loud all week, and then I'm talking a lot right now. Thanks, I appreciate it. To the blessing comment. Don't believe in God, but I believe in science. Persistent shedding of a virus, RNA and nasal. I already read that. A recent report suggests that COVID particles and antigen may persist in the human gut. We have seen studies on this, reviewed a few of those. So yes, that's 100% true. Much longer than 4 months. We've seen it up to a year. Even individuals who are asymptomatic at the point of follow-up. So yep, so that's like one of the big things that we can never say enough, is that even asymptomatic infections will cause these issues. Whether these represent viable viral particles is unclear. Expectedly, B cells in these individuals continue to evolve in a way that indicates continued antigen exposure. And autopsy examinations have revealed persistence of viral RNA in lung, endothelial tissue. So I should highlight that. In lungs, endothelial tissue, the linings, the inner walls of the vessels, and olfactory neuroepithelium, so in the vessels leading to the eyes, weeks after onset of symptoms, highlighting the potential serious implications of viral persistence. Reports of prolonged shedding of infectious virus for greater than 70 days in immunocompromised patients with evidence for continuous mutational evolution of virus in vivo suggest persistence of viable and replication competent virus for long periods in certain circumstances. So yeah, and that's a lot of people like to really hyper focus on the immunocompromised patient thing, but like it's not limited to just immunocompromised patients. It's more likely to occur, but it's not the only way it can happen. Could persistent shedding and feces mean they're contagious? And if not, does it skew wastewater data? We don't know. We don't know if it means they're contagious or not. There's a lot we still don't know. We don't know about that. Because if you're constantly shedding at low levels, because like at the top here, nasopharyngeal swabs have been showing low levels of viral shedding for a long period, for like 6 weeks after, and like that's the big gray areas. How long before symptoms show up are you infectious? We know it happens. We know they're infectious. We don't know how long before. And then at the end, it's weird. At the end of the infection, after the rapid antigen test is negative, that's the other side of the gray area where we don't know how long after it's no longer detectable that you're still considered infectious. Like if you were around someone for an hour at this low level, would you still infect them? We don't know. So my personal opinion is to remain on the ultra conservative side, because this is not something you want to mess with. Mark Johnson has said he doesn't believe they are infectious until ... highlighting the potential serious implication of viral persistence reports. Yeah, we already talked about that. Finally, a separate report claims persistent replication of COVID for a median of 85 to 105 days after recovery for 5% of individuals in a cohort. It's a big one. They can't until they can't control the infection anymore due to immunocompromise. I don't believe they are infectious until that's not clicking in my brain. I'm not sure what you're saying. So the evidence of this persistent low-level viral replication for 85 to 105 days way back in 2021 was found to happen in at least 5% of patients, which is supported with emergence of BA2.86. Yeah, that's the theory that's been going around, is that the viral persistence of the BA2.86 allowed for tons and tons of mutations to happen over time, and then it became infectious again. So it went from like a viral dormancy phase to a re-infectious phase. So it like went low level, dormant, mutated a bunch, and then became infectious again. That's the theory of how it happened. But then there's the second side of this, is like, okay, so we have a bunch of different variants, a bunch of different, the persistent cryptic lineage people not infectious until it's no longer controlled. And yeah, so controlled by the body, that's what you mean. Yeah. And then the other side of this is, okay, so we know that the viral persistence happens, and let's say a person has 3 infections. They got original Wuhan or Delta, they got BA2, they got XBB. So now you have all of these viral persistence, and they're sitting there in your body. They're gonna have, over a long period of time, all of these different viruses that are virally persisting in you of COVID can recombine and interact and cross-pollinate. And I think that's another side of this that we haven't like fully considered yet, is what happens when you have this viral persistent of different, recombination. But like viral persistent recombination, which is something we haven't really, like, I haven't seen considered in a lot of these papers yet, but I think that is something that likely can happen, is going to lead to another, like, third way that we're going to have more of this exponential mutation growth. Despite antibody responses Comparable to the non-persistent RNA group, these individuals had CD8 T cells, responses of significantly greater magnitude, possibly indicating immunological compensation. So because of the viral persistent, the body's kind of like staying in this overdrive for a long period of time, which can contribute to immune exhaustion, is something that you'll probably hear a lot. And that's why it could be linked to the viral persistence. Oh, I get what you're saying. I knew XBB was a recombinant, but yikes, I hadn't fully considered that. Yes, XBB was a recombinant, and yeah, that's something that I've been thinking about a lot. Is okay, so we know like viral persistence happens. What happens with these multiple infections that people are getting? And we know that these people are becoming immunocompromised after one infection or a certain level of immunocompromise, not as immune competent as they were before the infection. So this is more likely to occur with each subsequent infection. What's going to happen? These are just going to be like little viral factories of people in people, mutational factories. But I don't know. We can only speculate until we see proof of something like that. Yeah, that's the other thing, immune exhaustion from your body constantly trying to fight off these things. And then looking to reinfection. Reminder to drink water. Ugh. My vocal cords. Oh God, where the flowers and COVID is the pollen. I haven't played Last of Us. Isn't that the plot? The Last of Us. I think, yeah, fungal spores. Kind of. I'll give it to you. But yeah, it's possible. I'm not saying it's definitely happening, because this is just speculation. This is just thinking deeply about it. You have to say, it's one of those things where you say, okay, we know this, and we know this, so what if this? And that's the type of thing. I'm wrapping Christmas presents for the kids at the moment, so primarily listening to. Cool. Yeah, I'm excited for doing that in the future when I have kids. So to date, at least 362 ow, my leg just cramped. I tried to bend it too far. There we go. So to date, at least 362 genetically sequenced cases of reinfection with COVID have been documented. Again, this is back in 2021. We have way more cases of reinfection at this point. Significantly more. It is likely that this is an underestimate given the high threshold of evidence, blah, 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 blah. Outdated. So back then, the median interval for reinfection was 9 months, and that was around the time that you would get like a significant enough mutation that it would avoid immunity. But now we have so many variants, and it mutates so fast. It's only going to start mutating faster, that the reinfection period is going to get shorter and shorter and shorter and shorter. I was just talking to my dad on the phone earlier today, and he definitely has either COVID or long COVID. He's got a persistent cough or seasonal allergies right now. And he just had it during Thanksgiving. So if we're doing November, that's 1 month turnaround of him getting reinfected. So the mechanism of reinfection by human coronavirus is partly understood. It is unclear whether this is due to viral evolution, mutational escape, a decline in immune response, or a combination of the above. Likely a combination of the above, as well as social behavior, people not doing mitigation strategies, non-pharmaceutical intervention. That's what I was trying to remember. NPIs. Yeah, yeah. I think 11 days was the documented shortest turnaround between infections. But also, you can get a secondary infection while you're currently infected. So technically, that would be the shortest because you're still infected. So that'd be like a 0 day turnaround. But and there's been documented cases of that where there's two simultaneous COVID infections at the same time. What I'm really scared about is when you have like 3 or 4 simultaneous COVID infections at the same time, because a lot of times what we do, we're not sequencing all these people in the hospitals. So what they do when we have the hospitals overwhelmed with these COVID infections is they just group all these patients together, and that makes that type of situation a lot more likely, especially with these relaxed HICPAC recommendations that will likely be approved by Medicoin. So that type of scenario is not going to be out of the realm of possibility where you have like 3 or 4 different infections simultaneously of COVID. And we have no idea what will happen when you have that many different COVID strains simultaneously, which could also be something that's playing into these increases in deaths that we're seeing over the past 20 weeks. Although I think it's more just like the EG5 family, or that's my guess. So the mechanism of reinfection by human coronavirus is poorly understood. It is unclear whether, already read that. Reinfection with COVID has been shown to occur between 10 and 280 days following primary infection. So yeah, even in 2021, so shorter than what we were talking about, with some individuals experiencing a less or comparably severe illness the second time, and others a more severe one. Some governments expect vaccines to enable future infection future infections or so some governments expect vaccines to enable future infections or reinfections to act as immune boosters. That's the U.S.'s government strategy right now. Is you'll see in every single freaking document, every single article that the U.S. pushes out right now is that they're saying that we have high population level immunity when you combine vaccinations and prior infections together, completely neglecting the fact that an infection reduces your immunity theft. But that's our governmental policy. Make that green. No, we'll make it a blue. No, we'll make it a red because we're angry about it. Bananas. I think about 12 monkeys plot. We couldn't accurately track it. We haven't tested along the way. 12 monkeys plot. I don't know what that is. Family member is a custodian, was off 2 weeks, came back immediately reinfected, out 2 more weeks. Yep. And that's only going to get worse from here on out because of how many variants there are in circulation. And how increasingly transmissible, increasingly infectious these variants are. Because HV1 was already a super contagious, infectious one. Now we have JN1, which is off the scales infectious. But there is evidence that even after multiple infections, full vaccination, reinfections can result in more severe disease. So that's, even back then we're saying, yeah, it's not sufficient. This strategy is not going to work. A study of U.S. healthcare workers found that hospitalization was more likely following reinfection. The UK Siren study suggested that although prior infection provided approximately 80% protection against reinfection at 5 months, comparably with controls, assuming they mean non-vaccinated, non-infected controls, symptomatic reinfections were still seen with high virus loads and potential for transmission. So the virus getting back, that's a weird statement. I'd have to look at the study. I can't really speak on it. But while the incidence of reinfection remains unknown, the potential for reinfection at short intervals, especially with more severe subsequent infections, presents a serious risk with high levels of community transmission. The aspect is even more important now, given the potential ability of new variants in many parts of the world to at least partially escape the immunity response directly directed at the wild type virus or previous variants. So yeah, that was just basically talking about what we said. The movie 12 Monkeys circa 90s, Bruce Willis time travel, didn't see it. Nope, did not see it. It's probably before I started watching movies. I'm a 92 baby, so I'm only 31. That's terrible. I'm sorry. I hope you fully recover. Yes, I did, which is why AJ used that reference. Okay. Alongside the COVID causes profound immune dysregulation during acute infection. Yep, we know that. Functional exhaustion of antiviral lymphocytes has been reported alongside the production of cytokines akin to a polyclonal superantigen-driven T cell activation. So yeah, that's what we just read earlier. A superactivation-like region of the spike protein may drive responses that manifest as the multi-inflammatory syndrome in children, MISC. So that's what we talked about earlier. I stumbled over the word like 10 times. COVID has several important mechanisms of immune escape that may influence disease severity and favor antigenic viral persistence. The ORFB and NSP1 viral proteins are able to reduce multi-histocomplex. Damn it. I was trying to memorize this word earlier. Major histocompatibility complex. We're getting there. We're making improvements. Okay. Multi-histocompatibility complex. Okay. Expression 1. One expression and shut down host protein translation, disarming key components in the adaptive immune response, permitting antigen to accumulate and spread. There is evidence that COVID can infect leukocytes. Yes, that is true. We have seen that in many studies now, including T lymphocytes, in which the virus may use the CD4 molecule, facilitating further evasion of the immune response. That's interesting. That's saying that COVID could actually co-op and use that as a whatchamacallit. I don't know, when it uses that as like a replication host. I forget the phrase. So I'm going to quickly, that's a source I want to read in the future. So I'm just going to quickly write this into my list. So sorry, I got to explain what I did for people that haven't done that before. So these numbers afterwards, these are citations. Every citation in a published work will be hyperlinked. So you can just click on that and it'll take you down to the citation. So when they say something like this, and I'm like, ooh, that's really interesting, I can go, all right, so that's citation number 44. I click on it, it brings me down to citation number 44. And then I could go and read that paper. If I was, I'm really interested, I want to learn more about that before I wanted to finish this paper, I would go on a side quest and read that. This one is called SARS-CoV-2 uses CD4 to infect T helper lymphocytes. Cool. Just responding to a text real quick. Okay, so that's how you can do that. And then early work on the new variant suggests that N501Y mutation may facilitate immune escape by weakening cooperation between B cells. That's interesting. I'll have to read that one at a future date too. I think I'm going to make a new color for that. for read in the future. Black? Black. Do. Oh my god, you are so young. No worries. And then thank you. They described long COVID symptoms. I had to explain it to them. I'm sorry, that sucks. Rather, I'm older than I realize. No worries. I have it happen all the time to me. I saw your YouTube today. It's amazing. Thanks for all the work you do over there. Yeah, thank you. I initially made it because TikTok had been giving me tons. I mean, they still are giving me tons of community guideline violations. I'm able to actually win most of them, but and get things reinstated. And recently, I had one that got removed. I lost the appeal, but then a couple days later, they restored the video and didn't send me any notification on it. I literally got someone just messaged me. It was like, "Hey, your video's restored." I was like, "What?" But yeah, that's why I made the YouTube initially. But I really like it there because and this is where I'm gonna upload this video afterwards. But because I can like link all the papers. Yes, the citations. And hyperlinks to citation. What time to be alive? Yes, it's amazing. It's a really great thing. One of the best things I love about these papers. But also in the YouTube videos, I can link in the captions the papers and the articles that I'm talking about, so you can just go straight to it. But yeah, thank you. You're a scientist and a long hauler. Yeah, I'm sorry about being a long hauler, but yeah, I think a big thing right now is going to be like capturing all of this information and digesting it. And like right now I'm working on the like large scale stuff, and then eventually I'm going to filter down to and this is probably where people are going to get pissed off at me, is when I'm going to focus really on the subsystems, like the different reactions to figure out like upstream, downstream mediators. And I'm eventually gonna like build out like these graphics and stuff where I can talk about like these are the ways that you can get infected with it. These are the initial things that happen. These are the different pathways. This is what happens when it goes to your blood, and when it goes to this, and when it goes to that. These are the ways you can disrupt it, and figuring out from like there. It's my project, or what I'm doing with this. But I think that's something that needs to be done. So as another scientist, I recommend trying to do it too if you can, if you have the energy, that is. It's very hard to find resources like that on YouTube. Yes, exactly. And that's why I'm trying to build it there. Because they have, at least at this point in time, they have very, very strong ethics and community guidelines. So like I know that like my content won't be removed there. And it's a safe place for me to store everything. How does anybody buy immunity debt when lockdown was almost 4 years ago? Yeah, I don't know. And we didn't even have a lockdown. It was like 2 weeks. You didn't get punished at all for breaking it. I'm so tired. Yeah. Cool. So going back. Quick drink. Lubricate the vocal cords. So peripheral lymphopenia, leukopenia, and thrombocytopenia are key features of the clinical syndrome associated with COVID-19 among hospitalized patients. The potential impact of COVID on hematopoietic stem cells is also a cause for concern. Yep. So we've done a paper on that where COVID will infiltrate your bone marrow. Yeah, lockdown. COVID will infiltrate your bone marrow and will actually damage your the source of your T and B cells. It's kind of crazy. And also it's an osteoporosis risk. A lot of people develop osteoporosis from getting a COVID infection. So I'm just going to highlight that because that's true. And I like it. I don't like it, but it's what happens. Exposure to the viral spike antigen alone in vitro has been shown to cause functional and expansion deficits in Hematopoietic stem cells and progenitor cells, similar effects occurring in patients with continued antigenic exposure can manifest as bone marrow failure. That is interesting. I'll have to look that up. Bone marrow failure. Lots of good references in this paper. I'm going to write those down real quick, or else I am going to completely forget that I'm interested in wanting to read about those. So 45, that one is potential global impacts of the N501Y mutation on MHC multi-histocompatibility complex. Multi-histocompatibility complex. I remembered it. It only took like 4 hours. Presentation and immune escape. And then I think the other one was 47, but we'll scroll back up just to double check. I wish you could like click it and it would like do something and it would like go straight back up to where you were. That's my only qualm with the technology. Uh, 48, that's why I check. 48, that one is human. Hematopoietic hematopoiesis poietic stem, comma, progenitor, comma, and immune cells respond to ex vivo or ex vivo to sorry for the delay, but I don't want to forget because these are interesting. SARS-CoV-2 spike protein. Cool. Going back. General strike, renamed lockdown. Yes. So furthermore, there is evidence of aberrant CD4 and CD8 responses. Let me double check what that means. It's been a while since I used the word aberrant. Atypical or abnormal. Responses that may continue for longer periods following acute infection, even after 10 weeks. So yeah, we've seen that 8 to 10 months minimum, you'll have these immune system impacts. Even after 10 weeks, blah, 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 blah. Patients with mild infection exhibit increased exhaustion, gene signatures in CD8 T cells. So they mean that there's not a lot of them that we're seeing. Some patients develop autoimmune responses and clinically identifiable autoreactivity in severe COVID infection. These include a Kawasaki-like disease in children, anti-cardiolipin antibody-related thrombotic events, autoimmune hemolytic anemia, and thrombocytopenia, so blood clotting issues. Not clotting, but like throwing clots, blood clots. Broad autoreactivity has been identified among those infected with COVID, associated with impaired virologic control through inhibition of immunoreceptor signaling. So your body has an impaired response to viruses. This autoreactivity has been shown to correlate with the severity of clinical outcomes. There is also evidence that COVID can subvert CD8 T cells surveillance through escape. Wait, what? There is also evidence COVID can subvert CD8 T cell surveillance through escape mutations in MHCI, so multi-histocompatibility complex I, restricted viral epitopes. Longer-term impacts on the immune system are yet unknown, but particularly in light of possible viral antigenic persistence and the potential for reinfection, we should be concerned about the risk of lasting immune dysfunction and damage. There we go. That's the sentence that we need to focus on. So that was a lot of fancy science terms that ultimately mean, hey, we're worried that these immune suppression effects can happen for a very long period of time. So there's even been a suggestion acute COVID disease should not be regarded as should not be regarded as viral pneumonia, but instead considered an autoimmune disease. Yes, an autoimmune vascular disease is how we should consider COVID. Make that blue, because that's good. That's a good phrase that I should start saying. It's an autoimmune vascular disease. Okay, so COVID has also been shown to play a pivotal role in inducing the autoimmune hypothyroidism of Graves' disease. We echo the British Society for Immunology's call for urgent research in this area. So that's interesting. So that's another one I want to follow up with. Sorry, that means I'm going to have to type it down in my notes. Click. 57. SARS-CoV-2. So that's like one of the great things about research papers is that when you read them, you're like they've already done research, so they've already found all these sources and they've already summarized all these sources. So the great thing about it is that you don't always necessarily have to go out searching for things you're interested in. Sometimes you can just use the papers that you're reading to find other papers that are worthwhile to read that are relevant to the similar topic that you're looking into right now. So again, this guy focuses primarily on immunologic effects of COVID. So like this would be more stuff about the immune system. So SARS-CoV-2 plays a pivotal role in inducing hyperthyroidism of Graves. My voice got to the point where I have a deep voice now. Graves' disease. That means tomorrow my voice is going to be real sore. Hello. All right, that was me forcing it, but gotta work on my vocal training. Cool. Save. All right, and then we look at neurological and multi-system complications of long COVID. So I've done lots and lots of papers on neurologic stuff. So we're gonna know probably more than what they're gonna talk about here. I haven't looked too far into the multi-system complications of COVID. So that's gonna be something I'm gonna need to look more into at some point. So long COVID is a catch-all term conferred by patient advocacy groups to cover a variety of symptoms. So that's important to note. It's not just one thing, it's a cacophony of things. Work is underway to understand the diversity and causes of symptom presentation, but for our purposes, we use long COVID as a term to refer to post-acute symptoms. And I think that's very important. I think there are three distinct phases of COVID, or three distinct things that can happen. You can have the acute infection, that's what happens when you have the infection. You have the post-viral complications, which are things that are results of that initial infection. And then you have long COVID, which is long-term sustained issues that are systemic, I think is the way to put it. So they're worse than post-viral complications. So like for me, A post-viral complication is that I am now gluten intolerant because of my norovirus infection. That's a post-viral complication. That's for the rest of my life, but it doesn't impact my system. It just impacts my diet. But if I ignored that, then it would impact my system because of all the issues that happen when I do eat gluten now. So it could be considered a long, like, if this was COVID related, I wouldn't necessarily classify it as long COVID. I wouldn't do that, but it would be a post-viral complication. So there's different scales and different levels and different, I think there are 3 distinct things that we should be using. But that's a good way to say it. And that's what I've been thinking for quite a while now. So long term is the post-acute symptoms, but also they're more systemic than post-viral complications. So data from the UK Office for National Statistics suggests that 12% of those infected report symptoms lasting for greater than 12 weeks. So this is an early study on long COVID incidence. And they're saying that, like back then, the incidence was around 10%. Then more recently in 2022, it looked like it was about 20%, and it looks like it's going up. And that's because the more infections and reinfections you get, the higher the incidence is of developing long COVID. So personally, I think the incidence rate is around 33% right now. And that's the rate that was reported in children in early 2023. And that was on a very, very large UK study in children. So the REACT-2 survey estimates more than 2 million people in the UK have suffered from long COVID. So these are outdated, so I'm not going to read them. Although COVID has been described as a respiratory syndrome, evidence supports the involvement of multiple organ systems with fibrosis and inflammation in the lung, heart, kidney, central nervous system, liver, adrenal glands, bone marrow, lymph nodes, and gastrointestinal tract, and that's all true. And there's more things. Did they say brain? No. So brain would be like an example of another one. But we're finding that it's impacting more and more things than that. So COVID infection has been associated with serious thrombotic complications, including strokes, pulmonary embolism, and cardiac injury. Yep. Case reports of Parkinsonism following infection. So I'm guessing that means Parkinson's disease. Parkinsonism. Okay, so Parkinsonism is slow movement, rigidity, stiffness, and problems with walking. So that's a broad umbrella term. It's not the same as Parkinson's disease. I was going to say that, so I'm glad I double checked. In growing evidence of increased risk of neuropsychiatric disease up to 6 months following acute infection. Yep. The extent to which these effects are a result of direct infection versus the impact of the inflammatory response is to the virus is unclear. So we don't know if it's a direct cause or it's an indirect cause, but there's been mounting evidence that it is a direct cause of the COVID infection because the COVID can cross the blood-brain barrier and directly infect the brain and the spinal cord. How soon after COVID infection can you get it again? You can get a COVID infection while you have a current COVID infection. They have lots of studies, like even in this one back in 2021, you could get reinfected at 10 days. They have documented evidence of people getting reinfected 10 days after they cleared COVID. But basically you can have a 0 time delay. You can get it right away. I might run out of voice before I get to the end of this paper. Case reports, read that. So, the extent to which these effects are resolved directly. We already said that. Natural COVID neuroinvasion has been evidenced by autopsy, and now we have more evidence of seeing the direct effects of it. So this is a little outdated, but again, this is a 2021 study, so obviously it's outdated a little bit. Notably, T cells infiltrated the brain, parenchyma in COVID-19 patients. Yep, we've seen that. And then, that's important. So, and again, people like to keep comparing it to the flu. Oh, it's just the flu. It's just common cold now. You don't see this type of infiltration in the brain and immune cell activation in the brain in the flu. You do with COVID. They're not the same. A study of pediatric patients found that despite lower initial severity at the acute stage of the infection, pediatric patients demonstrated on average 5 months later a similar brain hypermetabolic pattern as that found in adult patients. So that's just saying that, yes, children can also get these long COVID symptoms. So even though it looks like their symptom severity and duration of illness are not as bad as adults, they have the same terrible effects. And then they're just saying we need more research into this, and there's been more research into it, and we're still learning more. There's a recent abstract on diffuse microstructural imaging, which looks at very, very small structures of the brain activity in long COVID patients, compared to people that had acute infections, compared to people that have never had an infection or not documented one, and aren't long COVID people. And they showed clear structural changes at the microstructural level. So that's going to be really interesting when that study comes out, but just to show that, to sort of paint the progress that's been made. Long-term follow-up studies of COVID infection show that symptoms of breathlessness. So a lot of people, like my father, even said this, that he's had this persistent cough, hard to breathe. Not hard to breathe. He didn't say hard to breathe, but like gets winded. Yep. And then after COVID infection, for about 5% of people still had visible lesions on their lungs, and 38% had reduced diffusion capacity, which means that their lungs aren't able to do the oxygen carbon dioxide exchange as efficiently. During quote unquote lockdown, friend kept delivering pizzas to large parties. Yeah, I was door dashing during that period of time. I was a door dasher because I had graduated from my grad program and I was trying to find a job. And I door dashed for a year during that time, and I can't tell you how many pizzas and stuff I delivered to people. Yeah, I've been sick in years. I haven't either. Wearing a mask. And also they found that wearing a mask consistently will improve your respiratory fitness, your ability to breathe well, and you can regain some of these lung deficits by doing this consistently. So it's sort of like a training thing. You've never worn a mask? Okay. Guess what, person? You're getting blocked. Bye. The last time I was sick was March 2020, flu A. Yeah, the last time I was sick was norovirus in either early 2019, late 2018. Yeah, I mostly mask and stay at home too. But sometimes I do have to get flown into work. I'll have to go early January to fly in again, which I'm very nervous about, which is why I'm going to be upgrading my mask to what we did earlier today. We looked at a new mask for me using my resource. So I'm going to get these, upgrade my mask game. So, conclusions. The above findings highlight that with COVID, we are not dealing solely with an acute infection with short-term clinical risks. There is the potential for significant long-term health implications. And while there remains much to be understood, the precautionary principle would advocate for taking approaches that minimize this potential risk, which we are not doing, and I 100% agree with doing what the author is recommending, not with what we're doing. I know Dr. Rubin and Lola Germs have talked about it, the portable air filter machine. Yeah. So one of the things that they did find, it hasn't been definitively proven. I looked at the study briefly, but it's a theory in contributing to the effectiveness of masks is that your breath warming the nose could make it so that the membranes are more active. It's better at either killing the virus from the heat there, or allowing you to activate your defenses easier. But again, that's theory. That's not that hasn't been definitively proven. That's so cool and interesting. Go nose go. Yes, the nose is very cool. Self-care, Dr. Rubin, Laughter and Light, and Lola Germs, keeping us safe. So to this end, public health policy should focus on significantly reducing community transmission alongside vaccine rollout. And yes, the author has advocated for a vaccine plus strategy for a long time now, where we can't rely only on vaccines. We need non-pharmaceutical interventions. And Patrick, woo! Takes a lot of people. Like, don't just listen to me. I'm just one person reading papers. I have my own interpretations. And Patrick, keeping us safe. But yeah, definitely always get information from lots of different sources. Lil can get bent. The other two are cool. Yeah, Lil has me blocked. Lil blocked me a long time ago. Focusing on hospitalizations and deaths as the only outcomes is short-sighted. Yep. And that's all the CDC's tracking. Hospitalizations and deaths. Relying on post-vaccine infection as an immunity booster may cause serious risks such as infections, and as such infections can result in increased disease severity, which is what we're seeing. Vaccine-only strategy, or saying that the population has effective immunity because of prior infections. It's just not how this works with COVID. I vetoed so many parties at my own house. Had to be the bad guy. Yeah, I mean, sometimes you got to be the bad guy. Guy in the colloquial sense. And then same. Yep. It is essential to reduce long-term risks from the novel virus until we understand them better, as well as reduce the risk of new variants emerging by suppressing transmission, which we are not doing. We are letting it rip. We are going to see the effects this winter. This is going to be our case study. People are going to write frickin' textbooks on the events that are happening right now in the future. Like, this is literally going to be in the textbooks. Anyways, sorry, existential. So there is now extensive evidence that transmission can be reduced through widespread use of face masks, better ventilation, and air filtration. Again, this is in 2021 that these statements are being made, and yep, nothing has changed. Contact tracing and isolation are established and effective methods at reducing transmission, absolutely. And governments, like the US government, should implement these mitigation measures in order to protect long-term public health and the effectiveness of the vaccines, because the vaccines can't be effective if you keep having these mutations over and over and over again. like XBB 1.5, it was out of circulation by the time we got the vaccines, and that's what it was targeted for. Yay. We made it to the end. So that's what we learned. It's a very good paper. Ow! My neck just cracked. Medical, political, environmental, social, yep. Historical time frame, yep. Yep. And people are going to be saying how dumb we were. And how these actions cause X number of deaths, X number of disablement, etc. Very cool paper and super validating stuff. Thank you, Patrick. No problem. But now I am going to call my brother and have a thing with them. So thank you all for stopping by. I'm going to upload this to YouTube so you can watch it there if you missed out on some stuff. Have a good rest of your day. I might do one more later today, or I might not. I think my voice is kind of beat, but we'll see what happens. Have a good one. Bye, everyone.